Hello student. In last lecture, we all studied the Z-bus formation by step method, and we studied the type 1 modification if any branch is added between the new bus and reference bus. And in today's lecture, we will see the if branch is added between new bus and old bus, then what will happen. Okay, so it is the modification where ZB is added from new bus to old bus. New branch is added and dimension of Z bus goes by 1. Okay, so because new branch is added, so whenever the any branch is added in this system, then our dimension of Z bus will be increased by 1. Okay, so consider a passive Z bus network in which branch with impedance ZB is added from new bus K to the old bus J. Okay, so what is the diagram? So this is the diagram for that. Okay, so now our branch ZB is added between a new bus K. This is a new bus K, and our old bus is a J. Okay, so now what will happen? Our equation will change. Okay, so VK is equal to ZB into IK plus VJ, because branch is added with the bus J. Okay, so now equation of VK is changed. Okay, so and if we put the equation of VJ, we already have the equation of VJ that by using this Z bus, that Z J1 into I1, then Z J2 into I2. So whole equation is present here. So if we combine this equation with this, then we finally get this equation VK is equal to this. Okay, so and our ZB into IK is combined with this IK current. Okay, so now our new row and column is get added in the with the old Z bus, then we get the Z bus new, and the values are like this: Z J1 plus Z J2 up to Z Jn, and here in the column Z J1, Z J2, and in the diagonal portion we have a Z Jj plus ZB. So whenever any branch is added between old and new bus, then Z bus new will be this. Okay, so put the all the impedances and you will get this formula. Okay, so every time when any branch is added, our Z bus will be added by 1. Okay. Okay, so this is the type 2 type of modification. Then type 3 modification is all about the branches added between old bus and reference bus. So now our branch is added in the old and reference. Okay, in type 2 we see that the branch is added between new bus and old bus. Now branch is added between existing two bus, old and reference. Okay, so what will happen? Now there is no any dimension change, because there is no any bus is added. Okay, so we add the branch between old and reference, so there is no any new branch will be sorry, new bus will added. So it is the modification where ZB is added from old bus to the reference bus. A new loop is formed, but dimension of Z bus does not change. Okay, so you can see that here that our ZB is added between bus J and R. So consider a passive N bus network in which branch with the impedance ZB is added from old bus J to reference bus R. By setting the VK is equal to 0, so we get this formula, or we can say that this modification will happen. Our Z old is added with this row and column. Okay, so our new impedance Z bus impedance will Z bus matrix will be like look like this. Okay, so VK is equal to ZB into IK, so this is the formula for that. If we put the VK is equal to 0, then this will happen. We can find the value of IK. Okay, so these are all the things that if we want Z bus new, then we can get it like this by Z bus old minus 1 upon Z JJ plus Z JB, and this is the matrix for Z J1 to Zn, and this is the matrix for Z J1 and Z J2. So this is the another form of matrix representation. We can also put this also. Okay, so we can either use this for this matrix, or we can use this. Okay, so this is the third type of modification, where we add the branch between old bus and reference bus. Okay, type 4 modification is branch is added between two old buses. Now there is no any reference bus, branch is added between two old buses. It is the modification where ZB connects between two old buses. New loop is formed, but dimension of Z bus will not change, because we uh, we are we are not adding any new bus here. Okay, so what will happen? Consider a passive N-bus network in which branch with impedance ZB connects to old buses. Okay, so impedance is get connect between the bus I and J. So what will be the what is going to change? IK here current IK plus II plus IK is flow through the bus I, and current IJ and minus IK is flow from this. Okay, so and current IK is flow from here, from the ZB. Okay, so if we put the if we form the formula for the voltage, then this is the formula. And here now we have a two different current for I for bus II and IJ. Okay, so now new two current is get added, and due to this adding, our Z bus will change. So now in addition to Z bus old, we have a this row and this column. Okay, so if we further solve this impedance bus, then we will get this formula. Okay, so you have keep in mind that if any in exam, if any particular modification is asked, then you have to solve whole process. But when there is any example is arrive, or any example is asked in the exam, then you only have to remember this last formula. Okay, so this is this is it for the your chapter number 4, symmetrical fault analysis. So in this chapter, what will we see? So first we see the some type of faults, then we will discuss the transient on transmission line. Then we discuss how we can derive the formula for RL type of circuit, and then we discuss the short circuit on synchronous machine when loaded and unloaded. Some synchronous impedance are also discussed in the previous lectures, and then we discuss the short circuit current calculation using Thevenin theorem. Okay, so then we see the some algorithm for the short circuit studies, and then we studied what type of modification is there when Z bus is going to change due to the branch is added between the new bus and the reference bus. Then type 2 modification is branch is added between two between new bus and old bus. And third type modification is branch is added between old bus and reference bus. And type 4 modification is branch is added between two old buses. Okay, so these are the all the modification that arise in the Z bus. Okay, so whenever any type of modification is asked in the exam, then write all the calculations and mathematical calculation as well as the figures. So this is it for your chapter number 4. In next lecture we will take the chapter number 5. Okay, so up to now, if you have any kind of doubt related to this chapter or material, I will send this material to your WhatsApp group. So if you want to study, or if you want to read all the questions answer, so it will be easier for you. Okay, so if you have any kind of doubt, then comment it down, and don't forget to comment your enrollment and your name in the comment box. It will be counted